Hi, welcome. In this video, we will solve problem minimum Wi-Fi routers required asked by companies like Amazon, Microsoft, Facebook, Apple, Uber, and Google. Now let's check out one more problem statement on advanced binary search minimum Wi-Fi routers required. If you are going to learn advanced binary search in very detail, this is one very good problem that you can add into your bucket list. Okay, you will get the concept of complete how basically advanced binary search work, what are the different possibilities of it, okay, by this single version. Let's see. Okay, minimum Wi-Fi routers required. So given an array of numbers here representing house coordinates, so here these are basically our house coordinates. House I represents the ith house on a one dimensional line. We have k number of Wi-Fi routers, so this is my k, this is k, and this is basically, you can say, house array. A single router when installed at a location X can be provide Wi-Fi signal to the to all the houses in the range X minus R and X plus R inclusive. So basically, if I have located one house here, one router here, right, at a position of X, it can give the range to here, suppose till some R limit, right, and till here, right. So this can be minus R plus R. Okay, so the range is from x minus r, basically x minus r to x plus r, x plus r. Okay, find the smallest value of r such that all houses have Wi-Fi signal. So we need to find this r range, right? We need to find this r range, and for this sample input, where we have 5 houses and the houses are represented like this. In this for one house at 14th location, at 3, at 17 and 17, and if we have only one Wi-Fi router, the output will be 8. So let's understand this problem statement, or sample input and output first. So we have this array, right, 5, and if I say 5 number of houses, right, and 14, 3, 1, 7, 17, something like this, right. If I say yes, 14, 3, 77, 14, 3, 7, 17, 1, right, 14, 3, 7, 17, 1. Okay, so basically the array was, I guess this is 17 and this is 7, right. Okay, so you can see here, basically I have represented all my houses at a position of 14, then at a position of 3, then at a position of 17, then 7, then 1, right. So basically you can see, right, the array that is given the location of houses that are not sorted, right, they should provide the position 1, then they should provide 3, then 7, then 14 and 17, right. So basically whatever the input is, we need to sort it, because I want to draw all the houses in a single line, right. So whatever the input is given, I need to sort it. Now I want to locate one Wi-Fi router here, such that all the houses will get the enough Wi-Fi range, right. So where I can locate, if there is only one router, can you tell me where I can locate the Wi-Fi router when I have only one router? That's basically middle, right. So I will simply find out what is the middle of it. So 17 is the total distance, 17 and 1. So if I two extreme houses, right, the 1 is the extreme one and this 17 is the extreme houses, right. So 17 minus 1, 16. So the total distance between these two houses is 16, right. And so what I will do, I will simply locate one house at the middle of it, one router at the middle of it. Suppose I am basically adding my Wi-Fi router at X. So again, this will be the range X plus R, and this will be the range X minus R, right. So basically I will add at the middle, so the position will be at 8, right. And so what is the, if I do 8 plus 8, And so the position not will be 8, I guess, because see, position will be 9, because 9 plus 8, I will do 9 plus 8, then it will get 17, and this house will get the Wi-Fi signal. If I do 9 minus 8, then this house 1 get the signal. So 1 minus 17, basically 17, and I will add in between, right? I will add the middle of it, right? So that 8 range at here, 8 range will be at here, and 8 range will be at here, right? And now you can see all the houses are getting signal. So basically how you need to figure out like where you need to place the your Wi-Fi router. Okay. This is basically you are getting the distance between the two extreme houses. If this is only case one when we have only a single router. So what I did, I simply find out the distance between two extreme houses. I got 16 and I have divided by 16 because basically the range will be twice. So it will be 8. And what I will do, I will take the first house, the position of first house, that will be 1 plus 8, and that will be 9. So my position will be at the 9. Clear? Basically, are you getting how basically we are solving it? So if I talk about some of the observations that we got from this sample input, is first one, that basically we need to sort the array. If I want to find out which is at the most of left, which house at the most right, so I need to sort the array, right? Then when, so this was the specific case when the router is only one. What will happen when the router will be two? What will happen when the router will be three? How we will find out the range then? How we will find out the range then? So what we will do for this thing, what we will do, we will solve one more sample input and let's understand. Okay. So let me give you one more sample input. So now let's check out this sample input. So we have an array of these numbers. Basically, these numbers represent the position of the houses. So again, like from the previous observation, we first need to sort the array. So I will simply sort the array. So this is my sorted array. Okay. So if I sort the first, I will get 7. Then the next will be, I guess, 26. Then the next will be 45. Yes, 45. Then 52. Then 65. Then 69. And I guess then we have, after 69, we have 73. Then 88. And in the last, we have 91. Right. So this is our sorted array. So what I will do, I will first basically represent in on a one dimensional line. So this is my one dimensional line and I will represent all the position of my houses. Right. So suppose this is 7, then we have 26 here, then we have, I guess, 45, then we have 52, very near, and then we have 65, 65, then I will represent 69, and then I will have 73 will be a bit more near. And if I say, then we have 88, I guess here, and then we have 91, that is also. So basically it will end up here. So I will remove this extra. So this will be my position of all the houses. And how many routers we have? We have two routers, right? So two routers, how we can locate? We don't have, I guess, two routers. Sorry. That my miss. It's not two routers. It's basically 7 routers. We will take more number of routers to provide the range. And again, the final answer, the final problem statement, that we need to find the minimum range. Think as a real problem, right? That you are working in a geo center and you need to find the minimum range of your Wi-Fi routers so that all the houses will get the enough Wi-Fi. Similarly, like here also, we find out the minimum range. Always remember that the goal is to find a minimum range. Okay. Okay. Now let's see basically how we can find out the problem statement, how we can solve this problem. So So now let's understand how we will get the how we will use the concepts of advanced binary search. Okay, so now we will use the concepts of advanced binary search. So in problems of advanced binary search, remember the range. Basically, I need to find a range, right? Minimum range. Okay, there will be some other problems where you need to find maximum distance. Okay, so maximum distance between two persons, or minimum distance between two persons or coordinates. And again, like this problem is of minimum range and the maximum range between two positions, right? All these problems are comes under advanced binary search, right? And remember, in binary search, the range can be find out between the array that was given. But in advanced binary search, the range can be from anywhere, right? Can be from anywhere. So basically find out minimum range. So what our first task will be, I will figure out what will be the range of my answers, right? So basically my answer will be the minimum range. But what could be the possibility of that range? Okay, so let me describe you enough in detail. So basically, think about that you have only one router. Okay, suppose k is equals to 1 when you have only one router. So it will be placed in the middle, right? So if I am placing at the middle, what will be the basically the distance? So can I say again, when we have one router, I will take the farthest point, that is 91. Okay, and for 7, 91 and 7, what will I will get the subtraction? So it will be, I guess, 84, right? And if it is 84, so I will divide by 2 because it is the range. So 84 by 2, it will be 24. So my first router will be located at 7 plus 24. That will be, I guess, 31, right? So somehow here 31, and so that like all my basically will get enough possibility range. Sorry, it's not 24. It should be 48. Sorry, my bad. It's 42, right? So 7 plus 42 will be that 49, right? So my position of Wi-Fi router will be at here somehow, right? And from here to here, the range will be 42, and from here to here, the range will be 42, right? So basically, I can say that if I have only one router, right? When we have only one router, again, let's see, when we have only one router, the maximum point I can reach, that is 49. And even, right, you can take any, instead of 49, you can take 91 also. In that case also you will get the answer. I will tell you how. Okay. But you can take 91. But remember that how I am getting to a conclusion, how I am approaching to a conclusion that the range, maximum range can be 49 because if there is only one route. Now, suppose when we have infinite routers, okay, or infinite means not simply infinite, there will be a finite, but greater than your number of houses. So suppose here the elements is 3, 3, 6, 7, 8, 9. We have 9 houses. So suppose router is basically greater than 9. If it is greater than or equals to 9. So if it is greater than or equals to 9, that means each house will get the Wi-Fi. Each house will get the Wi-Fi, right? So in that case, can I say my range will be 0? Basically, I am locating basically on the house, right? Wi-Fi will be here. Wi-Fi will be here, right? On the houses only. So basically, no range, no, not even a 1 meter, right? So can I say it will be 0? So now here I am getting the range for my advanced binary search so that I can apply. I am getting a range for my advanced binary search, that is from 0 till 49. 49 when we have only one router, 0 when we have infinite routers. Okay. And from here, basically what I will do, now I will apply binary search. How? Basically, I will figure out that 0 is there. See, what we will do, right? I have 0 as a range and 49 as a range, right? So basically how many routers they have given? They have given 7 routers. So basically my answer will be lie in between this range, right? 0 to 49, right? So what I will do, I will again, basically I will simply do it by binary search. I will find out all the possibilities. If I go with the linear search, okay, what I will do, I will basically try by 0. So if I am giving complete 0 range, so will all the houses will get the Wi-Fi? If the routers are 7, no. Then I will check with 1. If I am providing 1 meter range, will all the houses will get the enough Wi-Fi by 7 routers? No. Then I will check with the 2. If 2 is the range, will all the Wi-Fi, will all the houses will get the enough Wi-Fi if the routers are 7? Okay, so that will be a linear search. Okay, that will be a linear search, and the time complexity of linear search will be big of n, right? But I need to optimize it, right? I don't want to do 49 iterations. Okay, so what we will do, we will optimize it. And how I will optimize it? Basically, from 0 to 49, I have this range. What I will do, I will simply bisect it. So if I am simply taking a middle of it, what will be my middle of it? 49 by 2, it will be around 24, right? So what I will do, I will check with the 24. I will check with the range of 24, that this is my range. Now let's check all the houses will get the enough. Like if I am providing 25, what I will check? I will check if I am providing 24 range, how many routers will be required? Number of routers. Number of routers will be required. If number of routers are greater than k, the right, or basically not greater, if number of routers will be less than k, that means I can simply decrease my range. Think like a real problem. You are getting a range of 24, right? And number of routers that will be requiring is less than k, basically less than 7. What you will do, you will decrease it further. You will again take a intersection. So it will be, I guess, 12. Then you will check with the 12. Is it less than k? Yes, it is. Then you will again move. So now let's try to solve this problem. Okay. And then you will get what I am basically talking about. Right. So see how I will solve this problem. Okay, and as I have said that the answer will be lie between 0 to 49. So instead of 49, I can take 91 as well, right? Because right, 49, when I am applying binary search, the time complexity will be log n. So 49 and 91, it doesn't matter because it's nearly equal. So I can take the last position of houses and 0 for my range, right? So let's see, let's do it like this. So what I will do, I will create a quick table of it. So now let's see. So basically, if for my binary search, right, the minimum range is basically the lowest point can be S, the starting point can be 0, and the ending point is 91, right? So starting point is 0, ending point is 91, and I will find out the mid of it. So what will be the mid of it? 0 to 91, right? So basically, it will be around 45, right? So my mid will be 45, somehow near, right? And I will check with the 45 first, right? So how I will check it? So because my range is coming to be out as 45, so I will first house will be at 7 plus 45, right? This is my range. So 7 plus 45, so my router position, this is my router position, will be 7 plus 45, and that will be, I guess, 52, right? So the first router will be planted here, right? 52, so that this will be the range of 45. This range will be 45 when it will be planted at here. So let me put red here, that my router will be lie here, right? Now if I am planting here, the next basically the last range of this router will be, so it will be, can I say, from 52 plus 45? Basically, my router, the here this will be the lowest range, x minus r. This will be plus x plus r. So it will be 7 and 9, 91. Okay, yes, 91. So 45 here. That means I am going till 91. So can I say, right, by this range, my all the houses are getting Wi-Fi, right? 3, 4, 5, 6, 7, 8, 9. All the Wi-Fi, all the houses are getting the Wi-Fi? Yes. So yes, right. I am getting the answers. So what will be the outcome here? Basically, one router is required, which is less than K. Right. I can plant more routers. Right. I can plant more routers. So what I will do, I will decrease the range because I can plant. I have number of 7 routers, right? And I am getting only one router, which is very less than K. So what I will do, I will try to decrease the range. And how I will decrease the range? I will say end is equal to mid minus 1. Right. So if I do mid minus 1, what it will be? It will be 0, mid minus 1, then it will be 44, right? And I will find out the mid. What will be the mid? 0, 44 by 2, that will be 22, right? So again, I will start with 22. What will be my position of the router? So first house 7 plus 22, that it will be 29, I guess, right? So 29. So I will plant my Wi-Fi router at 29. Let me, it will be 29. So 26, 27, 28, 29 will be here, right? So my Wi-Fi router will be at here, right? So basically 22 will be this range, right? And what will be the last range of it? So basically, what is the position? 29 plus 22. That will be the last point of range. So it will be, I guess, 51, right? 29 plus 22, 51. So it will be around here, right? 22 here. Okay. So in that case, let me make this router a bit like this. Okay. So if this is the case, that means how many houses are getting the Wi-Fi supply? First one, second one, and third one, not the fourth one. Not the fourth one. 51 is the last point. 51 is the last point. So 1, 2. That means more Wi-Fi routers required here. Yes. So my next Wi-Fi router will be planned here at 52. Okay. Next second position. Okay. Or I will say second Wi-Fi router. So second Wi-Fi router will be at 52 plus 22. That will be 4 and 74. So the new position will be 74. So 74 here, right? So my new Wi-Fi router will be at here. Okay. So 74. So basically, if I subtract 22 from here, 52 house will get Wi-Fi, right? And what will the last range? So 74 plus 22, that will be 96, right? So it will go till here, 96, 22 here, right? So two Wi-Fi routers required, but the range is 22. Okay. So again, 2 is still bearable, right? 2 is less than K. So yes, I can decrease my range more. I can decrease my range more. So again, action will be same, mid minus 1, decrease the range. Okay, because I have 7 routers, right? Why should we use only 2 routers? We have 7. So I will decrease the range. So if I am decreasing the range, what will be the new endpoint? It will be 21. What will be a mid? So it will basically 10, right? Mid range. So my mid range will be 10. So now let's calculate the first router position. Basically 7 plus 10, that will be 17, right? So I will locate the Wi-Fi router at 17. So where is 17? 17 will be here, I guess. So this will be the router at 17 position, and 10 will be here. What will the last range? Basically 17 plus 10, that will be 27. So 27 till here only. Okay. What will the second position then? Because these two houses will get the Wi-Fi signal. What about the others? Right. So what I will do, I will choose the next house because I can't plant it here, right? This house is already getting the Wi-Fi signal. This house is already getting Wi-Fi signal. Why should I plant here? So I will take the next house, that is 45 plus 10, then it will be 55. So I will plant at 55. So 55, that means here I will plant and basically if I go back, it will be 45. So yes, this house will be get the supply, Wi-Fi supply, and 55 plus 10, 55 plus 10, then it will become 65. Okay, so 65 till here get the signal, and 55, that means here. Okay, now again, right? So how many houses are getting a Wi-Fi supply? 1, 2, 3, 4, and 5. What about the rest ones? So again, one more plantation, right? So I will choose the next house. 65 is already done. So I will choose the next house, that is 69 plus 10, that will be 79, right? So I will plant at 79. So 73, 79 will be at here, right? So if I do 79 minus 10, I will get 69, right? And 79 plus 10, I will get 89, right? 79 plus 10, it will be 89. So this house is also covered, this house is covered, this house, but this house is not covered, the last house, 91, right? So one more Wi-Fi router will be required for this one, right? And can I locate at here only, right? So that they will get the enough Wi-Fi supply, right? So how many Wi-Fi routers here required? 1, 2, 3, 4. 4 routers are required. Again, less than K, right? Bearable. K is 7. So yes, I can install 4 routers, but I want the minimum range. I want the minimum range. So again, we will simply decrease our answer. I will simply decrease my sample output. N is equal to mid minus 1. So what will be my answer? It will be 10 minus 1. That means 9. And what will be my mid? It will be 4. So now I will check with the 4. So now you can check it here, right? What were the different answers we got? We got 45, right? So that means all the ranges that are above 45 are cancelled, right? So see, that's why, that's the quality of binary search. Now we got the next range is 22. So 22 here somehow. So all the ranges here also cancelled. Then we got 10, right? All the ranges here got cancelled, and now we are getting 4. So all the ranges are cancelled, right? So from this much sample space, right, I am decreasing my sample space. I am at 4. I am checking with 4. So now let's check with 4. When you have 4 range, and range is equals to 4. So when we have range equals to 4, what will the first position? 7 plus 4, that will be, I guess, 11, right? So my first Wi-Fi router will be at 11. Okay. And what will the range? So 11 minus 4, that will be 7. 11 plus 4, that will be 4, 15, right? So 11 plus 4 will be 15. Okay, what about the next one? Now 7 is only getting the Wi-Fi supply board. 26 is not getting. So what I will do, I will install the next Wi-Fi, that will be 26 plus 4. So 26 plus 4, that will be 30. So I will install it at 30, like here, right? What will the range? Range will be 4, 26, and 30 plus 4, that will be 34, right? So by this one also, 30 plus 4, that will be 34. So only these two houses are getting the Wi-Fi supply. What I will do, I will decrease it further. So what will the third location? Now I am doing it directly. The third location will be 45 plus 4, 45 plus 4 at 49, and next range will be 49 plus 4, that will be 53. So I will install it 45 plus 4, that means 49. Somehow here 49, 49, and the range will be 45 subtracting 4, and the range will go till 53, right? So now these two houses are getting Wi-Fi supply. What will the next Wi-Fi installation? 65, because these are done, right? 65 plus 4, that will be 69, and the range will be 69 plus 4, that will be 73, right? So my Wi-Fi will be at 69, right? And the range will be minus 4 here plus 4 here, it will be 73. Okay. Now again, 88 and 18, 91 houses are left. What I will do, I will say 88 plus 4, this will be 92, right? And 92 plus 4, this will be 96, right? So I will install it 92 here, and by this, right, both the two houses will get the Wi-Fi supply. I can install it here as well, right, in between, because these were the last two houses. So how many towers, how many routers required? So you can see here, 1, 2, 3, 4, 5, 5 routers required. 5 routers required, which is again less than k, right? Again, we can further decrease our range. So end equals to mid minus 1, right? And what will be my new range? 0 to 4 minus 1, that will be 3, right? And if I take the mid of it, I will get 1, right? I will get 1. So let's check out with 1 then. So I will check with 1 now. And I will simply remove all these. So now let's check with 1. So now I will do it quick. So I have a range of 1. Okay, it will be easy. So one router will be at position 8, right? So if the router is at position 8, this house will get the Wi-Fi supply, and the range will be till 9 only, right? So I will install the next one at 26 plus 1, that will be 27. So this Wi-Fi, this house will get the supply, and the supply will be till 29 only. So I will install for this one new, so it will be 45 plus 1. So this Wi-Fi will, this will get the enough supply, that will be a range of 1, right? And if I'm install at 46, so it will be till 47 only, right? So for new one, for this one also 52. So for 52, if I install, it will be at 53, and the range will be at till 54. So I want a new one for this one. So 66, I will install it, right? So this will get, and the last range will be at 67, right? Because this is installed at 66. So new one I will install for 69. So it will be 70, right? So the last range will be 71 only. Okay. So new one for this one. So it will be 73. So it will be 74, and the last range will be 75 only. So new one for this one. If I install, it will be 89. It will be 90 only. Okay. So at 89, I installed it at 74 I. So new one for this one, right? So I will install 91 plus 1, that will be at 92. So this will be this Wi-Fi supply. So how many routers I have installed? 1, 2, 3, 4, 5, 6, 7, 8, 9, equal to the number of houses. That is more than, that is 1 is now more than k. So what I need to do, I need to increase the range. 1 is very less. 1 is very less. So what I will do, I will say s is equal to mid plus 1. So what was my mid? 1. So it will be 2. This will be 3. So now what will be the mid? 3 plus 2 by 2, right? So basically mid will be s plus e by 2, 2 plus 3 by 2. So that will be 5 by 2. Can I say 2 now? And I will check with 2 now. Okay. So now let's check it with 2. Let me remove all these things. So if I remove all this thing, I will create a new. So let me remove this. Last one position was 91, and this was 65. Okay. Now let's see, with a range of 2, how many houses will get the Wi-Fi supply. So now the range is 2, right? How many houses? So the my Wi-Fi router will be 7 plus 2. That means at a 9 position. So if I'm installing a Wi-Fi router here, this house will get range, and the range will extend to 11. So new one for this one. So if I install the new one for this one, it will be 26 plus 2. That will be at 28. So if I'm installing it here, this house will get the Wi-Fi supply, and the supply will till 30. So new one for this one. If I apply for new one, for this one, it will be 47. So this house will get the range, and 47, 48, 49, the range till 49. So new one for this one. So if I apply for this one, it will be at 54. So 54 minus 2, it will be the range 52, and 54 plus 2, it will be 56, right? So new one for 65 as well. So if I install for 65, it will be 67, right? And 67 minus 2, it will be 65, and 67 plus 2, that will be 69. Yes, so yes, these two houses will get a Wi-Fi signal by this single router that is at position 67, right? So this is done, this is done. Then I will construct for 73. So for 73, what I will do, 73 plus 72 basically. So it will be 75. So 75 minus 2, 73, and 75 plus 2 will be 77. So new one for this one. 88 plus 2, so it will be at 90 position, and 90 position, this house will also get the Wi-Fi, this house will also get the Wi-Fi ring, right? So how many Wi-Fi router I have installed? 1, 2, 3, 4, 5, 6, and 7. So that is basically equal to our K, or I can say within the limit. Okay, so basically I have 7, that is equals to K, right? So what I will do, I will try to again, let's see if it is equal. Can we decrease it, decrease the range more further? So let's try to again decrease the range. So and is equal to mid minus 1. So now if I'm doing and is equal to mid minus 1, so it will be 2 minus 1, then it will be 1. And now what is S? S is 2. Here S is now greater than E. And if it is greater than E, that means your basically your starting point. What is S? Starting point. What is E? Ending point, right? So your start is now greater than end, right? So there won't be any range. I will simply break it, and whatever the like last answer basically I am getting, I will simply like what is the last answer I am getting, I will simply present it, right? I will simply return it, and the answer will be 2. That 2 is the minimum range of routers. If there are 7 routers, so 2 will be the minimum range. Okay. So again, very beautiful question problem on this advanced binary search. I hope you got the complete understanding. Okay. So in the next video, I will show you the code implementation of it, basically how you can apply binary search and how you can find out the positions of the houses or of your router, and you can plant the routers. So let's see. In the next video, I will give you a code implementation of this approach. Okay. I hope you liked this video. Okay. See you in the next video.